Hey guys, can you hear me?
Yeah.
Hey, good afternoon, guys. All right, I think we have some people here. We can get started. All right. Are you guys, can you see my screen? No, not right.
No.
Oh, yeah.
Yeah, all right. All right, I think we can get started, guys.
Hello?
Hello? Yeah.
Hello? Hi, Aman. How are you?
Yeah, hi, Nick here. I'm good. But what about you?
Good. Just didn't hear you for a minute, so I was panicking. Just gathering some stuff here for that question. How's your weekend so far?
Good. That was good before.
Get any rain up there?
So for core valence electron, what should we know? So for core and valence electron, Steven, you should be aware. You should be aware of the fact that which atom has how many electrons. So I could ask you, like, carbon has how many core electrons, or carbon has how many valence electrons, questions like that. For instance,
No.
if we look at carbon, you can tell from the group number. It's group number 4, and that's how we know this guy has 4 valence electrons. Carbon has total 6 electrons, total 6. So the remaining 2 electrons are then the core electrons. So that's what you should be expecting. Or the other way to figure that out and just be more confident, carbon is 1s2, 2s2, 2p2. So this 2s2, 2p2, this is valence electrons.
That makes sense.
And this 1s2, this is the core electrons. Right. All right, I'm waiting for more questions.
Can you do the free response question from the chapter 8 worksheet?
Chapter 8 worksheet.
The hybridization in the molecular orbital theory multiple choice worksheet. The free response that number 27.
So number 27? Okay.
Yes.
All right, so here I think this example we did in the class.
Yeah.
For a carbon.
Because here's how I started. I started that we have the number 6 and then minus 2, and you divide that by 2, and that gives me 3. I just get confused with pairing them up.
Oh, can you repeat what you did?
I started with basically I looked at C2, and then I saw that the number was 6 in the periodic table, and then I subtracted it by 2, and then I divided it by 2. That gave me 3.
And, you don't have to do any of those calculations that you're doing. What you need to do is you have to make this molecular orbital diagram. This will already be given to you. This example is for C2. That tells me I have 2 carbons, one on the left, one on the right. And this in the middle, this is for C2.
Right.
Right? So what is the electronic configuration for carbon? We just did it. Carbon is
1s6,
1s2,
2s2,
2s2, 2p2, right? So if I have to fill that here, you see, this part is for a carbon. This part is for a carbon. This central one is for a C2. Okay. So carbon, we can see this does not even say 1s, so you can just ignore 1s. So it's starting from 2s. So 2s2, 2p2. So I'll do this 2s2 and then 2p2, right?
Right.
Yep.
And then this carbon is the same, 2s2, 2p2.
Mhm.
Now we have total how many electrons?
Or
So we have
S-
8, right?
We have total 8, right? 4 from here, 4 from here, total 8. So I have to put in those 8 electrons here in the center. So I'll do this, 1, 2, 3, 4. Now when you get here, you do 5, 6, 7, 8, right?
Mhm.
Does that make sense, everyone?
Why'd you put
Okay.
8 in the middle? Because that's how it was on the outside, or was that?
Yeah, there were 4 here, there were 4 here, so I combined them, that's total 8.
Okay.
And then you just follow each step. Each box can take 2 electrons, so you do 2 here, 2 here.
Mm-hmm.
And then when they're on the same level, so they were like this, right?
Right.
When they're at the same level, you do like this. 1 electron, let's have to put 4 electrons, okay? So let's have to put 3 electrons. Then I cannot do 1, 2, 3. What you have to do is you have to do 1 at a time, 1, and then 2, and then 3. And now in this case we have 4, so we'll do 4 like this.
Yeah.
So when you're on the same level, put 1 electron in one box, then the second in the second box. Then if you have more electrons, then go back to the first one, fill that, and then go to the next one. All right?
Okay, so how do you get the what was the formula for that one again? I forgot.
What is
So
what?
if the 2 bottom ones both have 2, so that kind of cancels out, right?
Yeah, right, that does. I mean, you don't have to remember that. You can actually just keep it very simple and just find the bond order just in case you forget what to do. If you just find the bond order, just calculate, just add, subtract all the electrons which are on the bonding orbital. So you see 2 electrons here. And then we have 4 electrons here. These are all bonding electrons.
Mhm.
So 4 plus 2 is 6. 6 minus the anti-bonding. Which one is anti-bonding? This one is anti-bonding. So 2. 6 minus 2 over 2. That's 4 over 2, and that's equal to 2. So your bond order answer is 2.
Mhm.
Right?
That's what I did. I did the bonding order right there, what you just did right there.
Oh, okay, so
It's just-
bond order, is that what you're saying? Bond order 6 minus 2 over 2?
Right.
Right. So this will only give you, like, if this was like a 9-point question, this will be like 5 points. This will be another 2 points, another 2 points. So don't just do this. You have to do this as well. Okay?
No, that's where I was actually getting stuck on that part, actually. I was trying to do everything, actually.
Okay.
On
Yeah.
the pairing part. That's why I asked you.
Right.
And then we're going to check to see if it's diamagnetic or paramagnetic,
Right.
right?
Yes.
And wouldn't it be paramagnetic, Amon?
So what do you decide this on? Diamagnetic, paramagnetic? Diamagnetic means your electrons should be
Paired?
paired. It should be paired or unpaired?
Should be paired.
It should be
And
paired.
paramagnet's unpaired.
So what do you see here? Are these paired or unpaired?
Paired.
They're
So
all
it's diamagnetic,
The answer is diamagnetic, yes.
which I wrote down too. I thought I had paramagnetic. Nope, I have that. How come it's a bond order of 2? Why'd you write that down where the bond order is at?
Here, we just did the calculation. So there's 2.
All right.
Can you explain what you mean by paired and unpaired?
Oh, okay. So you see this electron?
Mhm.
This is an unpaired electron. You see, if I have, this is my orbital. If I just draw 1 electron, that's unpaired. If I draw 2, that's paired. They're in a pair. This is not a pair.
Yeah.
And then don't look at the atom itself, okay? Look at the molecule, the C2. So the question is asking you that for C2, what is the bond order? Is it paramagnetic or diamagnetic? So your focus is here. You see this is paired, 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 paired. Everything is paired. If everything is paired, then it's diamagnetic.
So if one thing is unpaired, then it's just going to be all unpaired.
Yeah, so let's say the answer was this for some reason, okay?
Mhm.
So you see I have unpaired electron?
Mhm.
If this was my structure, this was my final answer, then this guy will be paramagnetic. Okay? Even if just 1 electron is unpaired, it becomes paramagnetic.
Mhm.
But this for sure is diamagnetic because everything is paired. But if you see 1 electron sitting here for some reason, then this will become paramagnetic. All right. Are you guys more questions?
I have a couple, but I'm waiting to see if anybody else has them before me. I'm just wondering, Amon, like on that
One more
same
thing, guys.
question that we
One
just.
more thing before I forget this. You see, this is
Okay.
actually a typo. This structure should not be this.
Which one?
The next question.
Right.
Now I mentioned this in the class, but for some reason I forgot to change it here. So you see, this is looks like pi sigma pi sigma.
Mhm.
Yeah.
It's actually supposed to be sigma pi sigma. Remember that?
Mhm.
I got that changed. I mean, in the class we learned this. In the class we learned this.
Oh, that makes sense.
Yeah, it's supposed to be down here. I mean, it should be sigma pi sigma. I mean, remember for oxygen and for fluorine and for neon, it changes to this.
Oh.
All right. So, I mean, you don't have to worry about, again, you don't have to worry about this on the exam. These figures will be given to you, right?
Oh, thank God.
Yeah. So you don't have to memorize any of this. You will be given the right molecular diagram. You just have to fill in the electrons like what we just did here and do this calculation for bond order and figure out their magnetic effect.
Mhm.
You guys, any questions on this? Because make sure you guys understand this because this is for sure on the exam.
Yeah, I got a question on that actually. Like for the bonding order, how'd you get that 6 minus 2 just to make sure?
Okay. So the bond order is number of electrons in bonding orbital minus number of electron in
Anti-bonding.
anti-bonding orbital. That whole thing then divided by 2. Okay. So you see the one without the stars
Right.
are bonding orbitals. The one with the star, they're anti-bonding.
Okay.
Right?
Right.
Right.
I have a question on ionization energy.
Okay.
It's more of a conceptual question, not even like
Uh-huh.
I'm looking at the notes and I'm looking at what we did in class.
Uh-huh.
So for ionization energy, is the question going to ask like which has the most ionization energy, or how is it going to be asked?
So for ionization energy, you're going to be asked 2 questions. One is for successive ionization energy, and one is putting in the order.
Gotcha.
Okay. So I can give you like 4 different atoms or 3 different atoms, and you have to put them in the order which one has the smallest ionization energy to the one which has maximum ionization energy. And then the other question will be successive ionization energy. So I will give you some data. Remember those jump ones where there's a jump, and that's how you recognize that it's going to be that molecule, I mean that atom from the periodic table. So I can give you some examples, okay?
Yeah. I
So-
remember.
So if we, let me open the periodic table. So let's say I give you lithium, beryllium, and boron on the exam. Lithium, beryllium, and boron.
Salud. 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 Jeez. I can't even hear you with my headphones on.
All right. So let's say I give you these 3 atoms and then ask you to put these in the increasing order of ionization energy. So ionization energy actually depends on two things. One is the atomic size.
Uh-huh.
The smallest ones are gonna have maximum ionization energy
Mm-hmm.
because they are so small. Their electrons are they're so close to the center that it's hard to remove them. That's why more energy it takes to remove that electron. Atomic size means smaller
Mm-hmm.
size, more ionization energy. That's why if you go to the right of the periodic table, ionization energy goes up.
Mm-hmm.
And the second factor, these go together, okay? First, you put things in the atomic size order, and that gives you the ionization energy. But then you have to look at the second thing, and that second thing is the orbital stability of the orbital diagram.
Mm-hmm.
Stability of orbital diagram. So what does that mean? Based on the size, these are already in the size order, right?
Yeah.
Lithium, beryllium, boron. So my order should be this: lithium, beryllium, boron.
Mm-hmm.
Boron is the smallest one, so it has highest ionization energy. All right? That makes sense?
Why does it have the smallest, even though it's the smallest one? It's just how it is, or why is that? Just how it is?
Like what is what? The size to the right goes down, ionization energy goes up.
Right.
Right? We talked about all the reasons in detail in the class. So boron is the smallest one because it has maximum number of protons.
Mm-hmm.
So in this case, beryllium is the smallest. I mean, boron is the smallest.
Right.
And that's why boron is going to have highest high ionization energy. Now, this is solely based on the atomic size. So now we have to look at the stability of the orbital diagrams. So for each one, you have to draw the orbital diagram. Lithium is 1s2, 2s1. Beryllium is 1s2, 2s2. And boron is 1s2, 2s2, 2p1. Right?
Mm-hmm.
So lithium is doing this. Beryllium is doing this. And boron is doing this. Now, when you look at these three guys, do you see this one is awkwardly more stable
Yeah.
compared to this guy? This guy is 1s2, 2s2, very happy, very content. Everything is fully filled. And then you look at this boron. If this guy loses this electron, it's going to become very happy, 1s2, 2s2, and that's very happy.
Yeah.
So this boron actually wants to lose this electron. Although it is the smallest size, so it should have highest ionization energy, but it also wants to lose that electron.
Mm-hmm.
Because of that, it takes us less energy to remove electron from boron. And that's why this order changes from lithium to boron and then beryllium. You see, on the other hand, beryllium does not want to lose the electron, although it's bigger than boron.
Yeah.
So these are two things, and they go against each other. Okay? So first, answer this based on the size. Make the order based on the size. So we made the order lithium, beryllium, boron. Then we're going to look at the orbital diagram stability, and we're going to look for any of the stability things, which we do notice here, that beryllium is exceptionally more stable because it's 1s2, 2s2. Does not want to lose that electron because then it's going to become half filled. Right now it's fully filled. On the other hand, for boron, it's going to be very favorable to lose this electron because then it's going to become 1s2, 2s2 after losing this 2 electron. That's why it's happy to lose that electron. That's why it takes less energy to remove electron from boron. That's why we shifted boron and beryllium. We exchanged them. We flipped them. It was beryllium boron. We changed it to boron beryllium. Okay. You guys, does that make sense?
Yeah.
Any questions on this
Yeah.
Why it changes? Or
Yeah. Why? Yeah. Why did you change it? Because I get confused with those a lot. I really do.
so, can you elaborate your question? Why it changed where boron and beryllium here?
Correct. Yes. Yes.
So that's where I was saying the orbital diagram is playing the role. More fully filled orbitals is better for atoms.
Mm-hmm.
So this 1s2, 2s2, that's a very happy state for beryllium. So it does not want to lose that state. It does not want to lose that electron. On the other hand, boron wants to lose that electron because if it loses this electron, it's going to become this, just like beryllium. So boron is willing to lose electron.
Mm-hmm.
And if it's willing to lose electron, its ionization energy will go up or down?
Down.
Down. That's why we see we moved boron in place of beryllium.
Because it's more likely to lose that.
Yes. Boron is more likely to lose the electron than beryllium because beryllium hates to lose its electron.
Mhm.
It's going to lose its status of being fully filled. Although this guy on losing the electron, boron, is going to achieve that fully filled status. Does that make sense?
Right.
So the iron, okay. Just one more time. So the ionization, the one that's last in the list, is that one with the most ionization energy or the least?
Yes, this is the most. You see, this one has the mouth open towards beryllium.
Mhm.
So see, always when you're drawing it like this side is the open side is the bigger side. This pointed side, this is the smaller side.
Mhm.
Right?
Okay.
So lithium has smallest ionization energy.
Mhm.
Boron is more than lithium, and beryllium is more than boron.
Gotcha.
Okay?
Mhm.
Right. So whenever you're going to look at ionization energy, you got to look at two things: atomic size and stability. Now, the second type of question that you're going to see is the successive ionization energy type of question. Let's say that I give you in the question, and you can find more questions like this on your multiple choice worksheet. Let's say I give you some data that we are in period number 3.
Uh-huh.
Okay, on our periodic table, we're on period number 3.
Mhm.
And then I give you the successive ionization energy data. And that data is this, that IE1 is equal to 100, IE2 is equal to 200, IE3 is equal to 400, and then ionization energy 4 is 3000, something like that. Now, we'll give you some options here, and then you have to pick the right answer. Okay. So let's say these are our options.
C.
What
Good
does
answer.
D say?
What's that?
What does number D say? Answer D.
D is Ga.
Oh, okay, sorry.
Gallium, right?
Gallium, yeah. So the question is saying that we are in period number 3, right?
Yeah.
And period number 3 is supposed to mean what on the periodic table? This. Let me give you some more.
That's 3s2 right there. That part.
Right. So period number 3 is this 4. Right?
Right.
So our atom has to be any of these 10 that we are, or 10, not 10, 8 atoms that we're seeing here.
Mhm.
Our atom has to be any of these 8. So we need to figure out based on the data, which one is it? When we look at our data has these numbers.
Mhm.
Again, ionization is the energy that you need to remove the electron. And it looks like that this atom is okay with losing the first electron, okay with losing second electron, okay with losing the third electron. But when you go to the fourth electron, this guy does not want to take it off. That's why we have to put so much energy, right?
Yep.
See, 100, 200, every time it's getting doubled.
Mhm.
If the next number was 800, we'll understand that.
Mhm.
But this guy is 3,000. That means we need to put in a lot of effort here. What does that mean? That this guy is willing to lose 3 electrons, but not the fourth one?
Mhm.
If it's willing to lose the 3 electrons, then it's group number 3.
Mhm.
So what is group number 3 on period number 3?
Aluminum.
Aluminum. So in group number 3, so this is 3, and on period 3, the answer is aluminum. Okay, so your answer is going to be C, aluminum. So you look for the jump,
Mhm.
and then the number you're going to pick is going to be the lower number. Okay, don't pick 4, pick 3. Okay.
Mhm.
Right. So that should be your second type of question.
Okay.
Right. Are you guys more questions?
Yeah. Give me a minute real quick. I have a few on the Lewis structure.
On Lewis structure?
I had
On
a
the
question
multiple
on
choice.
Lewis structure as well.
What's
For
that?
the structure, are you also going to be including polarity in like one question?
Yes,
Like
yes.
really combine molecular geometry, Lewis structure,
Right.
and polarity in one
It's
question?
going to be one question. Let's say I give you CO2 on the exam. I ask you to draw the Lewis structure first. I ask you the molecular geometry then, and then I ask you the polarity. This
Okay.
whole thing is 6 points.
Makes sense.
Right?
Mhm.
So for Lewis structure of CO2, I'll be doing this. Then I'll say it's linear, and then I know it's nonpolar. So this will give you 6 points. All right?
Mhm.
Why is it non-polar?
Because you see your carbon does not have any lone pair.
Right.
That's probably going to be your easiest bet. Since your exam is tomorrow, your easiest bet is that if you are in the central atom, does not have lone pair, it's nonpolar.
Right. Now, if it has a lone pair, that's when it's polar, correct? Come on.
Yes, most of the time again. If we go, well, yeah. There are some examples where it changes. I'll quickly give you that example, a hypothetical example. Let's say I have P in the middle, I have fluorine here, fluorine here, fluorine here, and then I have 2 lone pairs, one sitting on top, one sitting in the bottom. This guy is still nonpolar because these 2 lone pairs are canceling out each other. But they're not canceling out each other when it's this, when it's water. The only time, guys, they will get canceled is when you have 5 neighbors. Do you see you have 5 neighbors? 1, 2, 3, 4, and 5.
Yeah.
That's one neighbor, and these are 3 neighbors. Total 5 neighbors.
So it has to have a total even amount, basically, for them to cancel out.
Yes, I mean, here also you might think that they're canceling out each other. I mean, if we just look at this molecule, this also might look like that they're getting canceled, but they actually are not.
Right. But
They're
that's
not
a bent.
against each other. This is
That's
a
a
bent.
bent.
That's a bent shape. This guy is
Right.
pointing this way. This guy is pointing this way. They are not canceling out each other, whereas these guys are canceling out each other.
Okay.
Okay.
Just wondering, how long is your meeting? Like another 30 minutes, or how long is?
Yes, another 30 minutes, guys.
Okay. Yeah. So I have a question on the Lewis structure multiple choice worksheet 9, 10, and 11. I think they're the last problems. I could be wrong.
So Lewis structure. So which one's number what? Number?
They're the last ones, the last 3.
Okay, so Which of the molecule listed has a non-polar covalent bond?
Right.
Now if you guys remember, we did this when we were looking at polar, non-polar bonds, and let's say we look at water or any molecule, for instance. This is water.
Right.
Is this bond a polar bond or a non-polar bond?
Non-polar bond.
What
Polar.
makes you think that?
Right.
How do you find polar non-polar bond? Because when we learn Lewis structure polarity, we learn two things. For polarity, we look at two things. One is bond is polar or not, and then we look at symmetry, right?
Yep.
This
Symmetry.
question is not about symmetry. This one is just saying, is the bond, see the bond, is the bond polar or not the molecule.
Right.
So how do you find bond polar or not? So you're gonna be looking at this table.
Right.
You see oxygen is 3.5.
Can't see it. It's too
And
small.
so oxygen is 3.5. Can you see it now?
Yeah, I see it now. Yeah.
So oxygen is 3.5 and hydrogen is 2.1. So this is my H2O.
Right.
So oxygen is 3.5, hydrogen is 2.1. What is the difference?
More than 5.
More than 5.
More than 0.5, sorry.
1.4, right?
Yeah.
So 1.4 difference is more than or less than 0.5?
More.
More. So this guy's going to be polar, right?
Yep.
So the difference has to be
Less
than
than
0.5 if it wants to be non-polar.
Right.
But if it has to be polar, it has to be 0.5 or more than 0.5.
So how would you write the Lewis structure out for H2 then? Since it says the answer is H2.
Right. So H2 is this.
Right.
This guy is 2.1. This guy is also 2.1. What is the difference?
None.
0 difference, right? So if my difference is 0, will you call this polar or non-polar?
Non-polar.
So this is a non-polar bond,
Which gives the answer.
which is the answer. Because we just learned H2O is polar. NaCl
Right.
is also polar. Look at chlorine. Chlorine, I think, is 3. And sodium is how much? Sodium is 0.9. Chlorine is 3.
That table's on Canvas. You write them on?
I mean, you have it. You have the worksheet, right? So you can just see it there.
Oh yeah.
It's the last page of the same worksheet,
Okay.
and that's how you're also gonna see it on your exam.
Okay.
And these are very similar questions. More questions, guys?
So when it's asking for ionic, like, what's it mean by that? Like, same worksheet. Is it saying like electronegativity?
I might not ask you ionic, but see, so difference from 0 to 0.4 is nonpolar, and then more than or equal to 0.5 is polar.
Polar. Right.
And if it goes beyond, if it goes more than 1.9, it becomes ionic. So you see magnesium is 1.2, oxygen is 3.5. What is the difference? 2.3. And 2.3 is more than 1.9.
Yeah.
So that's why G and O, this is 1.2, this is 3.5. My difference is 2.3, which is more than 1.9. That's why this bond is going to be ionic.
Alex has a question about electronic affinity. Alex says he has a question about electronic affinity.
Thanks for mentioning. That's a question in case. So so as you mentioned here, you should know that which one is endo, which one is exo. So which one takes energy, which one does not take energy. To know the order of electron affinity and ionization energy, yes, you should know both of them. As we learned here, for ionization energy, we went in all this detail. For electron affinity, if you go from left to the right, so for electron affinity, The electron affinity is the love towards electron.
Yeah.
So the things on the right-hand side, they are non-metals, right?
Hmm.
They love their electrons more. Loves electron more. So they have more affinity. So your electron affinity goes up when you go from left to right. And when you go down, electron affinity decreases. And this way it increases. So this is the order. You don't have to here think about anything else. It's just a size. It's a matter of if you go from left to right, electron affinity goes up. If you go from top to bottom, electron affinity goes down. The other thing you got to remember that electron affinity has a negative sign. So negative sign means it's exothermic. And on the other hand, ionization energy is the energy you have to put in. So ionization energy is the energy you're putting in, so this must be positive. So endo. And if you know that much, you should be good for your exam.
And it makes sense also talking about exo and endo because like when you think about it like physically
Mm-hmm.
for like fluorine, it's wanting to gain one more electron. So to
Right.
gain, you have to put in energy, right?
No. To gain, they actually give off. See, think like this. Think like there are kids who want a candy. After getting candy, they become very happy, right?
Uh-huh.
So same with fluorine. When you give them electron, they become very happy. And they actually, when they become happy,
They
so
give up.
there it's opposite to the kids. So they're gonna give off energy, and then they're gonna sleep. By sleeping, I mean they're gonna become very stable.
Mm-hmm.
So fluorine, when it gains energy, fluorine or any nonmetal, when it gains, or any atom for that matter, if they gain electron, they
Uh-huh.
give off energy because they become more stable.
Mm-hmm. That makes sense.
Okay.
Would you be able to do a question on stoichiometry, Amon, or no?
What about any specific question that you have in your mind?
Yeah, I'm trying to go from. I'm looking at the number one. I don't. It doesn't have the name of this worksheet, but it says there are a mole of carbon atoms and 4 moles of C4H8O2. I don't know
So,
if that's a stoichiometry or if that's a moles one or what that
so
is.
I have
Probably
a
most
question
atoms
here.
one.
This is a stoichiometry worksheet, multiple choice worksheet for stoichiometry.
Right.
And then the first question, if you just see the first question, it says if we have 2.5 moles of, oops. So it says if we have 2.5 moles of oxygen, which is this, with 4.6 moles of C3H8,
Yeah.
will produce dash moles of waters.
Yeah.
So this
Now
is a stoichiometry question, right? You have
No,
moles. Yeah.
that's not it. It's actually from the moles to atoms worksheet, but here I did have a few questions on this worksheet now that I'm looking at it.
Right.
Can you do number 12? I'm a
Number.
little bit, because I'm sure 13 and 14 are going to be the same.
So number 12, it says the reaction of 1 gram of sulfur. So I have 1 gram of this guy.
Mm-hmm.
And then I have 1 grams of oxygen.
Mm-hmm.
Produced 0.8 grams of SO3. So 0.8 grams of this was produced. The percent yield of the experiment. So to find the percent yield, do you remember the formula for percent yield?
No, that's where I'm being honest.
Percent yield is the theoretical yield. Actual yield over theoretical yield. So like your actual score over a theoretical score. That's how you can remember. Like if you got 80 points out of 100, you do 80 over 100, right?
Right.
So whatever you got here, so how much product was made. So what do you have to put here? Why is my pen note?
You get theoretical yield.
What's that?
How do you get theoretical yield?
How do we get theoretical yield? So let me first put the formula. So it's actual over theoretical times 100. Actual, do you guys realize what is the actual yield?
Yeah, It's the actual equation, right?
It's the 0.8 grams of SO3, right?
Yeah. So you have to find the limiting reactant first, right?
I'm sorry. This is not actual.
Yeah, that's theoretical, right?
Yeah, that's a theoretical.
And you get the actual from the actual equation.
Word is not. I mean, just drawing on the word is not so easy. Yeah, any comment?
Well, it's been a good semester, Amar. I'll be honest with you.
That's great. So yeah, we were saying we were doing actual over theoretical. So actual we don't. Actual is what we will get to know. I mean, so they're saying when you did the experiment, we reacted 1 gram of sulfur with 1 gram of oxygen, and we made 0.8 grams of SO3, right?
Mhm.
So this is what we actually made. This is the actual yield.
Mhm.
So we know the number on the top, which is 0.8 grams actual. We don't know the theoretical, right?
No.
That makes sense, guys?
Yeah, that
Mhm.
makes sense.
Today, lost you guys. You good?
Yeah.
Good.
Okay. Okay. So for finding the theoretical yield, theoretical is how you find those. Remember, I have to go from moles of this to moles of this, moles of this reactant to moles of my product.
Right.
Do that for both the reactants, and then you get to the moles of the product. That's
So-
how you do this one too.
So, for example, I'm going to go from the 1 gram of sulfur to moles of sulfur, or what is that?
Yes. Moles of
Moles.
sulfur, then moles of SO3, and then grams of SO3.
And then we're going to start, and then the next one's going to be 1 gram of sulfur and just do the same thing, right?
1 gram of oxygen to moles of oxygen
Mhm.
to moles of moles of SO3,
Mhm.
and then grams of SO3.
Okay.
So whichever one is going to be the smaller number of these two,
That's
Yeah.
going to be our
that's what
dividend, right?
that's your theoretical. Yes, that's your theoretical yield.
Whoa. Wait, the smaller one is what?
Theoretical yield.
Okay.
See, when I'm doing this,
Mm-hmm.
I'm theoretically figuring this out, right?
Yeah.
So that's my theoretical yield.
So when you're doing that, is that the same way how you find the what's it called?
Limiting reactant?
Yes.
Yes. So let's say this one is going to be a smaller number, okay? I don't know, but let's say this is a smaller number.
Okay.
So my sulfur, see, let's say I get 10 grams here and I get 20 grams here.
Yeah.
Who gave me 10 grams? Sulfur, right?
Yeah.
So sulfur will be the limiting reactant.
Okay.
Okay.
So the smaller, it's also going to be the limiting, right?
The smaller is the limiting reactant,
Uh-huh.
and how much grams you make is called the theoretical yield.
Okay.
Okay. The one who gives you the theoretical yield is the limiting reactant.
That makes sense.
Okay.
Yeah.
So that's what will go down here, the theoretical yield in grams.
Mm-hmm.
Okay.
Aman, I have a question on the balancing redox equations. I was just practicing them.
Balancing redox is not on the exam, right?
No, it's balancing
It's balancing in general.
yeah.
Oh, I thought it was okay.
Like balancing this reaction. N2 plus H2 gives me NH3.
Oh, okay, good. Okay.
It's just the basic form of balancing then. It's not like acidic or
Not
basic.
not the redox one.
Are we doing any gas law for like the chapter 5?
Right. So for gas law, I think there'll be 2 questions as I said in the, or just 1 question. Do you guys have the study guide?
Yeah.
Yeah, I have it with me right now.
Yeah.
Actually, let me see if I can find it.
I think
You
there's
said,
1 question.
yeah, I think you just said 1 question because I'm just seeing, and then you also said examples of endo and exothermic.
Right. So that's it from your 2 chapters. Chapter 5 and chapter 9.
Right.
So chapter 9 is the gas chapter. And from there, you're probably just going to see, remember those equations, P1, V1, P2, V2?
Okay, so we're only going to do equations like that, not like effusion rates.
No.
Okay.
Like these ones. And equations will not be given to you, so you got to remember them, okay?
Right, okay.
What's an oxidation number again, Amon? Can you go over that real quick?
The oxidation number? Sure.
Yeah.
So oxidation number, guys, we have to find our oxidation state or number is the same thing, or the charge. So let's say we'll start with the easy example. We have CO2.
Uh-huh.
And I'll find the oxidation state of C and O.
Right.
I'll divide this molecule into 2 halves.
Mm-hmm.
Start from the right-hand side.
Mm-hmm.
Oxygen is what charge based on periodic table?
-2.
And we have 2 of them, so -4. So this side is
+4.
+4. So my carbon is +4 and oxygen is
-2.
-2, not -4, right?
Yes.
Yeah. So that's the oxidation number. Does that make sense, Nick?
Yeah, that makes sense. So just look at the what was the multiple choice worksheet to practice for that one?
I think it says oxidation numbers.
Okay.
Yeah, here.
Oxidation numbers. Okay.
Oxidation state.
Can you do a quick example on hybridization?
Sure. So let me finish the oxidation state because you might see little different examples. So just so that you guys understand.
What was you said for C? You were just doing that one up there. Can you scroll up to that one real quick just so I can see it?
This one?
Yeah, real quick. Just real quick.
Yeah. I'll also post a video for this so you guys can watch this later as well.
Okay. You didn't post the one from last week though.
They are now posted. I posted them today morning.
Okay.
I totally forgot, and then no one emailed, so it seemed like no one wanted to watch it. So, but I still uploaded it today. So let's say we have SO4 -2, and we want to find the oxidation state of S and O again.
Mm-hmm.
Again, we're going to divide this guy into 2 halves. We know oxygen is -2 times 4, -8. So this side should be what, guys?
It should. Well, do you want the right answer or a pretend answer?
The pretending answer will be +8, right? It should be +8.
Yeah.
I mean, -8 +8, but it's not that simple, right? We know that this is -2.
Uh-huh.
So this should be percent.
Somebody posted 6.
Yes, so it should be +6, right? Why is it +6? Because if we assume this to be, let's say we can't figure that out for some reason, okay? Let's say this is X. My sum for the oxidation numbers should be equal to the number on the top.
Oh, okay.
So X plus -8 should be equal to -2. So X minus 8 is 2, which makes it X minus 2 plus 8, which is +6. That's why this X is going to be 6. And
so would you say it's like algebra in a way, Aman?
Yeah. And then let's say I would give you this example now, MgSO4, I'm asking you for the charge of the sulfur in this case. I mean, the answer is going to be the same, but just looking at it a little differently, okay? In this case, we have 3 atoms to look at, MgSO4. And I'm asking you for sulfur on the exam. The one that I'm asking you on the exam, don't start with that, okay? Start with the ones that we know for sure from periodic table.
Mm-hmm.
We know that oxygen is -2 charge.
Yeah.
And we also know magnesium. Magnesium is what charge based on periodic table?
+2.
+2. And 4 oxygens are -8.
Mm-hmm.
What should be the charge of sulfur?
+6.
It should be +6. Why is it +6? What is the total charge on MgSO4?
0.
0, right? There's no charge. MgSO4 is neutral, right? When I write MgSO4, that's a neutral atom. There's no charge on the top. So this is +2, so this must be +6. That will become +8, which will negate this -8.
Uh-huh.
So that's how we got that this should be +6. So I could ask you a question on the exam where it's already a polyatomic ion, like SO4 -2, or I could give you MgSO4 and then ask you for charge of the atom.
Did you have a couple examples of the ones that are unusual that we won't know?
I mean, they're not, I mean, they're all the regular questions that we have done. There's nothing unusual, but just that you guys got to remember how to do all different kinds one.
Gotcha.
So you should know how to do something as simple as this. You should know how to do something like this, which has a charge on top, or you should know how to do the ones which have 3 atoms in them.
Yeah.
You see 2 atoms, C and O. 2 atoms, S and O, but a charge. And then third example, we have 3 atoms. So these are 3 different ones that you should practice.
Okay.
We expect acid, or yeah, you're gonna expect for the nomenclature, guys. It's everything. So all the nomenclature. So your exercise C should be something that you should be studying for your exam.
Okay, that's
That
good to know.
includes ionic, molecular, and acids.
Okay. And where's the next one? Yeah, back to what I was saying about earlier. Like, I think the question I have is from like from the moles worksheet,
Uh-huh.
because I reprinted that one. The first one said is then I have a feel like on the rest of them, because I did a lot of them on my own, which was good, and I got them right. But the last 3 and the first part I got stuck on.
These last 3.
Let's see. Yeah, it says does it say the answer is A? 1.4
Yeah.
2 4. Yeah, I got stuck on those 3. Yeah.
So you're given the atoms. So you're given that we have 52.06 grams of CO2,
Right.
and you want to find the oxygen atoms in it. How many oxygen atoms?
Right.
So if I have 52.06 grams of CO2, I have to first change it to moles. So from grams of CO2, I'll go to moles of CO2. And then from moles of CO2,
The ratio to oxygen, right?
right, to the moles of oxygen atoms. Once I have the moles of oxygen atoms, I'm going to continue this down here, okay?
Got it.
Moles of oxygen atoms. Everything good?
Mhm.
Moles of oxygen atoms to oxygen atoms. Okay, and that will give us the final answer. So we know that 1 mole of CO2 is 44.01 grams of CO2.
Mhm.
And then moles of CO2 to moles of oxygen atom. What is the mole to mole ratio here?
Well,
2 to
One.
1.
2 to
No,
1.
1 1.
One CO2 gives me 2 O's, right?
why is that? That's just how it is, or?
Well, CO2. There's 2 oxygen.
Oh, yeah. That makes sense. Yeah. There's 2 oxygens in CO2.
Right. So 1 CO2, if you break down 1 CO2, it's going to give you 2 oxygens.
Mhm.
Okay. And then from 1 mole of oxygen, 1 mole O has how many O atoms?
6.022 times 10 to the 23rd power, which is Avogadro's number.
Right. So you just got to solve the whole thing. You should get the answer.
Okay, so that's just basically how we do the next 2 as well.
Molecular. Well, that one is actually, the last one is pretty straightforward. Okay. Right. So 19 is just the opposite of 18, opposite direction.
Okay.
So from moles, from atoms, you're going to moles. 18 was going from grams to the atoms. So this question is starting with atoms and then going to the mole.
Okay.
And so sodium carbonate is Na2CO3. Okay. So you got to know the formula, otherwise you can't solve this. I think you
Now-
can. Even then, you can. Even if, it's carbon atoms, so you do need.
Yeah.
If
Now
it's
for the now something like number 20, we'll see on the exam as well, Amon, or no?
number 20,
Yeah, something like that, or no?
yeah, that's probably the easiest one.
Yeah.
Really?
Yeah,
Yeah.
it's asking for mass, and you're given moles.
When you think of it, like it's asking how many grams is going to be in that big molecule. And oxygen is already 16 grams in itself, so you know it's going to be a big number with that many,
Uh-huh.
grams in there.
So basically, you have to just go from moles to mass, right? That means you need to find the molar mass of this guy.
Mm-hmm.
So find the
Hey,
molar mass of the whole thing from periodic table, and then you just find the mass. And it's actually for 1 mole, so it's going to be the same number as the molar mass.
Mm-hmm.
Hey, Amon, Alex has a question saying, for the nomenclature portion of our exam, should we expect acids or just ionic, polyatomic,
Right.
and molecular compounds, or anything?
Right.
fair game.
I answered this already, and then yes. So it's
Ionic, molecular, and acids.
so it's anything. Yeah.
Okay, so it's just all fair game. You have to just know that worksheet by heart, right? Basically. Practice it.
Yeah. I mean, you can't memorize it.
I mean, not memorize it, but just memorizing the formula.
I mean, yeah. You gotta know the rules for nomenclature. If
Mhm.
you know the rules and you practice them, then I
Mhm.
think you should be fine.
Fine.
But yes, they're gonna be all different types.
For the isotopes,
Huh.
I don't understand how a question could be asked about isotopes. Like
Okay.
I don't know.
Sure. So for isotopes, let me give you an example. Okay.
Okay.
Let's say I give you these examples. Okay.
Uh-huh.
And I ask you which of these two look like isotopes to you of each other.
Mhm.
So let's say this is A, this is B, this is C, and this is D. Okay.
Mhm.
So are A and B an isotope, or is A and C an isotope, or is A and D an isotope, or is it let's say B, C are the isotopes, or B, D are the isotopes, or could be any of these combinations. Okay, I think I made most of them. So if you look at this, what should be your answer? Which ones are isotopes? What do we mean by isotope, first of all? They have what same?
It's a different version of the same.
Right.
Is it the same number of protons, right? Or electrons?
So their protons should be the same, right? So if I have carbon, right? Carbon is 6 and 12.
Uh-huh.
Another isotope of carbon is 6 and 13.
Yes.
Another isotope of carbon is 6 and 14. Do you see this 6 is constant?
Yeah.
So their number of protons are always same.
Mm-hmm.
So it's BD for this one.
So yes, it should be B
Mm-hmm.
and D
Okay.
because it's 6 and 6. So look for the common atomic number, the number on the bottom, not the number on the top, or the smaller number. You see smaller number out of these two is this, these two is this, these two is this. Smaller number is always in the bottom, and that's the atomic number.
That's just how it is, huh?
Yep.
Okay.
That's how we learn to write all the atoms. If I have to write nitrogen, I have to write like this. My mass number goes on top, atomic number goes in the bottom. And the isotope for nitrogen, if there is an isotope, should be like this. Its atomic number is never going to change. Mass number can change. And that's how you can recognize isotopes. Make sense?
Mm-hmm.
I have a question for the thermochemistry.
Uh-huh.
The worksheet number 33. Can you please help me with that one?
Now you're not doing all the questions, right, on thermochemistry?
No.
Okay. So thermochemistry, number 33, you said?
Yeah.
Yeah, that's what I said. Don't do these questions. These are not on
Oh,
your...
okay. These are the copies. Never mind. I was just looking at my past
What
notes.
questions you gonna see on the exam with me?
Just the endo and exo.
Endo and exo. So keep it easy then. You don't have to do all these problems. It's gonna be something like this. You see this example, like this, number 3.
Yes. I hate that one.
So number 3. You hate this one?
Yeah.
Okay. So the type of questions you're gonna see is gonna be something like this. Like which example is endo or exothermic? So you basically have to figure out. Always remember when you're putting in heat. Wait, what is this? You are putting in heat. That's endo. Okay? Or you can think the other way. System getting, that's also endo. So if I am making coffee,
Mhm.
hot coffee, when I'm boiling the water, for water, it's endo. Okay?
Mhm.
So don't think about the first one. I think it's going to be much better. Think about the system.
I think what's hard with that is knowing which one is the system.
So read this. Ice melting, ice is the system. Water evaporating, water is the system. Boiling the soup, soup is the system. Condensation of water vapor is the system. You see, ammonium thiocyanate and barium hydroxide are mixed. The temperature of the solution drops. So when you're talking about the reaction, then the reaction is going to be your system. Now, again, if this confuses you on the exam, this is something where you can ask me during the exam.
Okay. Would I be able to ask like which is the system?
Yes, you can answer that,
Okay.
and I
Can
have
I
to
ask
answer
you?
that.
All right, that'd be cool.
Okay, so because it has to be clear in the question that what is the system.
Okay.
Yeah, I'm not testing anyone's skill in like if they can make sense of the wording. I mean, you should be, but then if it's confusing, then you can certainly ask me on the exam. So let's say, for example, a coffee cup sitting on the table and cooling down. Then I'll have to tell you my system is what? Is it the bench that we're talking about, or is it the coffee cup?
Okay.
So if you see something like that, ask me what is the system, and I have to answer that. Okay.
Okay.
Now, are the questions for the thermochemistry going to be like that, or are they going to be like a problem that we have to work out?
So no math problem for thermochemistry.
Oh,
Just
okay.
that's it.
There will be a question on combustion though, right? With empirical molecular formula.
The empirical
For-
formula, yes. But that's a chapter. What I think I have separate worksheets for them.
Mhm.
So if you go into your
Yeah, because
empirical
the one you were
formula,
telling me earlier, Ramon, that one has combustion too. But
what
then
the
it's
empirical
different.
formula?
The one that you were telling me with the combustion propane of C3H8 parentheses produces CO2 in water. Because it says that that's a combustion.
I mean, when I say combustion, see, I can give you any question on stoichiometry. It could be combustion, it could be any reaction, it doesn't matter. If I'm giving you a balanced equation, and I'm asking you if I'm going from A, so let's say I'm going from A plus B to C plus D,
Mhm.
and there are moles right next to them.
Mhm.
It doesn't matter what type of reaction that is.
Yeah.
If I give you, I have 1 gram of this, I have 2 grams of this, and how many grams of this I can make, it doesn't matter what type of reaction that is. Just follow your stoichiometry. Go from A to C, go from B to C, see whichever one is small, that's what you're going to use, right? Are we good here, guys? Does that make sense?
I think so.
But yeah, this is not, by the way, this is not a stoichiometry question. Okay. So do make sure you do questions like number 6, 7, and 8. We did this in the class on the last day on Wednesday.
Right.
Did this many times when we were doing this chapter. And you're going to see very similar question like this where to find the empirical formula and molecular formula. Okay.
Aman, you don't have to go over it because I know we're like short on time, but I wasn't here for the wavelength, frequency, energy, or any of that.
Right.
But it seems like it was pretty just much just plugging in information into the
Right.
equations, right?
Uh-huh.
Okay.
So yeah, there are these few formulas that again will be given to you on the exam.
Yeah.
C is equal to lambda times a frequency. C is a constant.
Mm-hmm.
And I think you should be able to go back now and watch that video for office hours if you want.
Okay, cool.
This is frequency
Mm-hmm.
and this is wavelength.
Okay.
So first of all, you should just know what they all stand for.
Yeah.
C is the speed of light, lambda is wavelength, and frequency, mu is frequency.
Mm-hmm.
So if I give you, and this is constant, so it's always given.
Mm-hmm.
I can give you lambda, ask you to find frequency, or give you frequency, ask you to find lambda.
Okay.
Another thing you should know is if lambda goes up, frequency goes down, and energy also goes down. So if I have a photon that has a higher wavelength, it's going to have a lower frequency and lower energy. You will see a question on this as well, guys. Does that make sense, guys?
That be like that question you said? Is it gonna have like like you were saying, lambda's gonna go up and that's gonna go, the frequency's gonna go down?
Right, that could just be a conceptual question.
Right.
If wavelength goes up, what happens to frequency? Or what happens to energy? Let's say the question says if I increase the wavelength, then what's going to happen to the frequency? Will it decrease or will it increase?
It'll increase, right?
Right, they are opposite. So if my wavelength is increasing, frequency is decreasing.
Uh-huh.
Okay? So you, I could ask you something like that on your test.
Mm-hmm.
And then remember to do problems where you can do delta E is k1 over n initial square minus 1 f square. And also 1 over lambda is RH, 1 over n1 square minus 1 over n2 square. At the end, when you guys get the answer, make sure to flip it to get the lambda, okay? So if the question is asking you that we go from n equals 6 to n equals 4, the question could be asking you for lambda, or it could be asking you, oh, somebody's getting a lot of disturbance from someone. Is this you guys?
Mm-hmm.
Are you good?
Yeah.
Okay. All right. So it could ask you to find lambda, or it could ask you to find energy, delta E. Okay. If the question is asking for wavelength, use this equation. If the question is asking for delta E, then use this equation. These constants K and RH will be given to you. These equations will be given to you.
Okay. So when you said to flip the answer, is that for both of them?
No.
Just for lambda?
Only for lambda. You see, this is already delta E. So when you're going to solve this, you will get delta E. When you will be solving for this guy, if my final answer 1 over lambda comes out to be, let's say, 1.8 to 10. Let's say I plug in everything and I get this answer. In order to find lambda, I'll have to do this.
Oh, gotcha. Okay.
Right? So don't forget this step. Now also remember, lambda always positive, whereas delta E can be positive or negative. Positive or negative. You don't have to do anything. This equation will do it for you.
Okay.
If you follow that Ni is an initial and Nf is n final, you don't have to figure out positive negative. Your calculator will tell you positive or negative.
Okay.
Okay? But don't forget that this is I initial F final. If I'm going from N6 to N4, what is initial, what is final?
6 initial and 4 is final.
So 4 is final and 6 is initial. So this is going to be my Ni, this is going to be my Nf. Okay? So
And
if
will
you
those
find that in,
equations,
what's that?
those will be given to us, those, the delta E and lambda equation?
Yeah, these two equations will be given to you, and these constant value will also be given to you.
Okay, good. Okay.
Right?
Mm-hmm.
Are you good, guys? If you will still have questions, then email me your questions, okay?
Okay.
Or go and watch your previous offline.
Okay.
Alright guys, and I'll be posting this video once I render the video, and I'll post it on Canvas, okay?
Okay.
Thank you.
Alright, see you guys.
Thank you.
Bye. Bye, no worries. Bye. Take
Bye.
care, guys. Bye.